Hello dear students, today we are going to discuss about the class 9 science chapter 1 matter in our surroundings. So this is purely strictly based on our NCERT syllabus, so you can follow directly. So without wasting much time, we are directly moving. Matter. Matter is okay. What is matter actually? Air, water, stones, sand, clouds, pencils, books, everything is made up of matter, right? So what is actually matter? Matter is everything in this universe that occupies space and has mass. Space and has mass. So this is the pure definition of matter. Matter is everything in this universe that occupies space and has mass. So what are these constituents? What are the constituents of matter? So according to early Indian philosophers, every living and non-living things is made up of five basic elements called Panchatattva. So Panchatattva, what is Panchatattva? Panchatattva means five items, right? That is air, water, earth, sky, fire. Therefore, matter is a composition of these five constituents. So according to early Indian philosophers, matter is a composition of these five constituents, that is air, water, earth, sky and fire. So moving to the physical nature of matter, matter is particulate in nature. This means that matter consists of particles, as you can see in the microscopic image of the cube. So this is, you can see a cube, actually it is a cube. We can consider it as a matter. Okay. So we are taking this microscopic image. What you will see? Different types of something, right? Some dots, right. So this means that matter consists of particles, as you can see in the microscopic image of a cube. So for example, if we put a drop of red color in water, the color of the water turns red. So you are adding red color, and what is the color? You will get the the puri water. What happens? It has pura water, it will changes to red in color. This happens because the particles of red color mix with the particles of water. The particles of red color mix with the particles of water. The size of the particles of matter is very small. That means the size of the particles of matter is very small. Okay, that means if you are adding a single drop of red ink to a glass of water or a tumbler of water, what happens? The entire water just changes to red color, right? So the size of the particle of matter is very small. And they can be broken into further particles as well. They can be again broken into further particles. Let's do one activity that is mentioned in your NCERT textbook, that is on dilution of a colorful solution. As shown in the figure below, we can still see the color. Okay, they are mentioned with KMnO4. Okay, KMnO4, potassium permanganate. Potassium, POTASSIUM, potassium permanganate. Okay, what happens? We can still see the color. This means permanganate. This means there are millions of particles present in the color which just divide themselves on dilution. Now we are moving to the characteristics of the particles of matter. There are four characteristics of the particles of matter. That is, the particles of matter are very small, and the particles of matter have spaces between them. Particles of matter are continuously moving. Particles of matter attract each other. So among these four characteristics, particles of matter are very small. That means that we already discussed, right? Activity 1.1. That means we are adding a single drop of red color into a glass of water. What happens? The entire water gets changes to red color. Now the second one is particles of matter have spaces between them. That is, okay, you can see spaces between them while you are adding some sodium chloride, or no, common salt you are adding to the water. What happens? You will get salt solution. So particles of matter have spaces between them. That means the salt we are adding to the water, that gets attracted by the water molecules and get inside this the spaces between them. So particles of matter have spaces between them. Now the third one is particles of matter are continuously moving. Think about our amma is preparing biryani or something in your kitchen, and you will get the smell. Why? That the particles of matter are continuously moving, and particles of matter attract each other. Okay, particles of matter attract each other. Like in the case of solids it is tightly packed. Okay, as we already discussed, you can see so many videos in my channel itself. Particles of matter attract each other. Okay, moving to the next slide. Particles of matter have spaces between them. Particles of matter have spaces between them. Okay, spaces between them. Now, have you ever wondered what causes salt to get dissolved in water? So this is a typical representation of how you are going to dissolve salt in water. So this one is particles of water magnified millions of times. So particles you can see here, and you're going to, okay, I'm adding salt, but the figure is okay, same sugar and salt, same going on. Okay, I'm adding sugar to this. Okay, adding sugar to this, so I add to the water and stir. So you can see sugar here, and water plus sugar, you will get what? You will get sugar solution here. What you will get? Sugar solution here. SOLUTION, sugar solution. So here what happens here is salts get, or okay, sugar here, okay, or salts get dissolved in water because their particles have spaces between them. So salts get dissolved in water because their particles have spaces between them. The particles of the salt get in between the spaces between the particles of water, and a mixture is formed. So what happens here is, suppose this is our water molecules, okay, water particles. So here in between these water particles you can see so many spaces, right? In the spaces, in this space, okay, I'm going to change the color. Okay, this green color, you can see this is our salt particle. So the salt particle get occupied in the spaces between these water particles. So what happens, there is a mixture is formed. This is a mixture is formed. So, and this is what is called salt solution. Okay, salt solution. Okay, while you are writing all these things in your notebook, instead of the sugar, make it into salt. Okay, all this sugar you have to change into salt. Okay, it's better. So our question is, have you ever wondered about the, oh, so okay. We cannot see these particles through naked eye. So we cannot see what is inside the sugar solution, or what is inside, or the particles inside the sugar solution or salt solution. We cannot see these particles through naked eyes. Now the next point, that is particles of matter are continuously moving, that we will understand from this area. Particles of matter are continuously moving. Okay, continuously moving. Okay, all of you please listen here to the this figure. Okay, you can see here particles are continuously moving. This particle is moving in this direction. This particle is moving in this direction. This particle is moving in this direction. Okay, it's up to them. They are moving continuously inside something, right? So particles of matter are in motion, movement, motion, of motion all the time, hence they possess kinetic energy. Yeah, energy, energy, uh, energy for moving, or the energy related to movement is kinetic energy. Energy related to movement is called a kinetic energy related to movement. Kinetic energy. So here the particles are moving, that means one energy is there, that is kinetic energy is there. So kinetic energy is the energy that is produced due to motion. Kinetic energy is the energy due to motion. And the kinetic energy of the particles also increases on heating. Okay, you can see what happens when we are particles of matter are continuously moving. Okay, all of you please listen here. I'm going to increase the temperature. Okay, also increases on heating. Okay, I'm going to increase the temperature. What happens here? Okay, the particles are moving very randomly, or very speedily, or very fastly. The particles are moving. That means the kinetic energy of particles also increases on heating. Kinetic energy increases on heating. Particles of matter are continuously moving. The same thing we are going to discuss it again with two more points. The particles of matter intermix on their own with their other particles of matter. For example, salt in water, various gases in air, ink in water. So the particles of a matter intermix on their own with other particles of a matter. Diffusion is process. Okay, kinetic energy is there. Another one term is diffusion. The process of mixing two different types of particles together is called the diffusion. So here some of the examples: salt in water, various gases in air, ink in water. These all are examples of diffusion. What do you mean by the term diffusion? The process of mixing two different types of particles together is called diffusion. You can see here before diffusion, red color. This is red color particles, right? Red color particles, and these are orange color particles. These are orange color particles. So before diffusion, what do you mean by diffusion? Diffusion means intermixing of particles. Intermixing of particles. So after diffusion, you can see here in this figure, after diffusion what happens? Red is somewhere. Okay, they are intermixed, right? So diffusion is the process of mixing two different types of particles together is called diffusion. Diffusion also becomes faster on heating. Like kinetic energy, diffusion also faster on heating. Now the fourth point that we are going to discuss about the characteristic property of matter is particles of matter attract each other. Particles of matter attract each other. So the particles of matter are always held together because of force of attraction between them. For example, I'm talking about ice. I'm going to talk about ice. You can see ice cube, right? This is an example for ice cube. Okay, suppose this is an ice cube. So what happens here inside this ice cube, there are so many particles are there, and these particles are held together by strong force of attraction between them. And the amount of this force between the particles varies in the different forms of matter. So the amount of this force of attraction varies in different forms of matter. Solids have highest force of attraction. Solids have the highest force of attraction. Solids. Then comes liquids. Then comes gases. Right? Okay. So that is why we cannot move our hands through a solid object. We cannot move our hands through our solid object because it is tightly packed. That means the force of traction is very, very high. The particles are so tightly bound, Similarly, the particles of gases have the least force of attraction in them. We can move our hands easily in the air. This is because of the particles of air are loosely bound. We can also move our hands through water. Okay, compared to water, what swimmers are doing, we can also move our hands through water or liquid matter, but not as freely as we can in the air. This means that they are also loosely bound to some extent, only to some extent, right? So particles of matter attract each other because of force of attraction between them. Because of the force of attraction, this is the main point. Because of the force of attraction between them. Right, force of attraction between them. Okay, moving again to the next slide. So we can arrange the forces of attraction between different types of matter as gas, liquids, solids. Which one is a more tightly packed? The solids is more tightly packed than liquids, than gases. Okay, now we are moving to these different states of matter. So gas is one phase of matter, yeah, liquid, solid. Then the fourth state of matter is plasma. Fifth state of matter is Bose-Einstein condensate. So which are the states of matter? Solid, then comes liquid, then comes gas, then comes plasma, plasma, then comes Bose-Einstein. Bose is one scientist. Einstein is also a scientist. You know, Einstein condensate. Cbse Bose, no, this is Indian scientist. Bose and Einstein, you know, condensate. Bose-Einstein condensate. Oh. Now, the solid states. We are going to solid states. Solids have these three properties. They have a specific shape. They have distinct boundaries. They have a volume. Think about an ice cube. I'll draw an ice cube here, right? Ice cube, right? It's cube. Okay, it's cube. So it has a definite shape, right? It has a specific shape. What is the shape here? It is a cube. It has distinct boundary, right? It has distinct boundary. It's a cube, right? It has a distinct boundary and it has a volume. But there is less kinetic energy among the particles in solid. What do you mean by kinetic energy? As we already discussed, the kinetic energy is the energy uh, takes place when it's moving, right? Moving time energy, right? Movement. Kinetic energy is the reason for the a movement of the particle in an atom or in a particle. Okay, sir. Okay. So there is less kinetic energy among the particles in solids. They are generally arranged in an order. They are generally arranged in an order. I'll draw. So it is generally arranged in an order. Okay. So it is generally arranged in an order. Right. This is the order. So suppose I'm going to draw a face of a cube. You can see it is closely packed and it is definitely arranged, right? Okay. Okay. Now, yeah, they possess fixed shape, but that's why it possesses fixed shape and it cannot be compressed. It cannot be further compressed. Now, the force of attraction is maximum among the particles of solid. You know, there is no gap between two particles, right? So, the force of attraction is maximum. The force of attraction is maximum among the particles of solid. There is not much space between the particles, therefore, they cannot be compressed. So, why solids cannot be compressed? The question. The force of attraction is maximum among the particles of solid. There is not much space between the particles, therefore they cannot be compressed. Clear? Okay, listen here guys. So a rubber band, some of the examples we are going to point out. So a rubber band and sponge, you know about rubber band and you know about sponge, right? They change their shape only when we apply force onto them. Okay, while you are giving force, when you are applying force to rubber band, what happens? It stretches. When you're applying force to sponge, what happens? It skews, right? It might appear to you as if salt is taking the shape of the container in which you put it, but actually each of its grain has its own definite shape. Because suppose I bought some salt from shop and I'm going to transfer that salt to a bottle, right? Now what's the shape of that salt? The salt acquires the uh, shape of the container, right? But it feels like it, but it's not the case, because each salt particle, you know, this is a small salt particle, it is that shape itself. So it has its own definite shape. Sponge has air pores in it. You know sponge, right? It has air pores in it. When force is applied on it, it gets compressed. When force is released, it regains its shape as air get again filled in the pores. Okay, so this is an example, typical examples, rubber band, sponge, etc. Now moving to the liquid state. Liquids have following properties. They have fixed volume. I'm buying 2 liter milk from the milkman, or I'm buying 1 liter oil, right? Sunflower oil. Liquids do not have a fixed shape, but they don't have a fixed shape. When I'm filling this oil in a plastic bag, then I'll get the shape of that plastic bag. When I'm filling it in a bottle, then I'll get the shape of that bottle. That means liquids do not have a fixed shape, but it possesses a fixed volume. Okay, the force of attraction in liquid. Now we are moving to the next concept, that is force of attraction. Force of attraction in liquid particle is less than that of solids. Therefore, there is a space between the particles of liquids and they can flow easily. Okay, now all of you please listen here. This is a particular face of a cube of solid. So this is tightly packed, right? There is no space between two particles, right? Yes. Yeah. Now this is example of solid. Now moving to the next phase. Okay. So here you can see there is some particle and a space between these particles, right? So the force of attraction in liquid particle is less than that of solids. Therefore, there is a space between the particles of solids. Okay, you can find some spaces in between the particles, right? So they can flow easily. That is the reason for the fluidity of liquid. Fluidity, Fluidity. So there is a space between the particles of liquid, so they can flow easily. They cannot be compressed. That's why they are also called fluids. They can be called as fluids. Okay. You might have seen that liquids take the shape of the container in which we put them. This is because of the particles of the liquids have high kinetic energy. They always keep on moving. Yeah, right. That is another one question. Why the particles of liquids? No. Why liquids take the shape of the container in which we put them. Okay, in which we put them. This is because the particles of liquids have high kinetic energy. Kinetic energy means the particles is moving this way, this way, this way, this way, right? So particles are moving. So particles are moving. Why particles are moving? Because there is space between these particles, right? Because of the space, they can move in this. Okay, move. They can move, and that's the reason for the fluidity, and also that is the reason for the why liquids take the shape of the container in which we put them. Matter can diffuse into liquids, whether it is solid, liquids, or gases. So they can diffuse into liquids. Matter can diffuse into liquids. For example, I am going to add some sugar to water. What you will get? Sugar solution. So here what happens? This solid sugar molecules or sugar particles get dissolved or diffused into liquids, right? Similarly, I'm going to add some milk to water. What happens? Okay, I will get milk, dilute milk, right? Okay, and of course I'm going to give carbon dioxide to water for getting the carbonic acid or your what soft drinks. So this is all because there is a space between the particles of liquid. So there is space between the particles of liquids. You can see there is space between the particles of liquid. So particles of other matter can slip into those space. Another one question is this, you will get: matter can diffuse into liquids. Substantiate. Matter can diffuse into liquids, whether it is solids, liquids, or gases. This is so because there is space between the particles of liquid. So particles of other matter can slip into those spaces. Now, diffusing solids into liquids. An example, mixing sugar and tea. Diffusing solids. Here, sugar is the solid particles and tea is the liquid particle. Okay. Sugar, solid, sugar and tea. Right? Okay. Sugar plus tea. Here, sugar is, what is here? Diffusing sugar particle into tea. Okay. Diffusing liquids into liquid. Now mixing ink in water, ink in water. Here ink is also in liquid state and water is also in liquid state, and you are going to dissolve ink in water. What happens? Diffusing liquids into liquids. Okay. Diffusing gases into liquids. For example, the presence of oxygen and carbon dioxide in water is an example for diffusing gases into liquids. Okay. Okay. So in this session, you will get three or four questions. I'll sure. Now we're going to discuss about the gaseous state. So gases have the following properties. They do not have fixed volume. They do not have fixed shape. They don't have fixed shape nor fixed volume. They don't have fixed shape nor volume. So the particles of gases have the least or almost no force of attraction between them. Therefore, the particles have a large number of spaces between them and they can freely move in any direction. I'm going to draw the face. This is face A. This is space B and this is space C. Okay, you can see here the difference between these spaces. So here the particles are arranged in a definite order. Yeah, right? Okay. Okay, all of you please listen here. Now this is, we are going to here, there is, you can find spaces between these particles and here you can see most of the spaces are empty. So the particles of gases have the, this is for solid, this is liquid and this is gas. Okay, so the particles of the gases have the least or almost no force of attraction between, there is no force of attraction between them because almost the space is empty and therefore the particles have a large number of spaces between them and they can freely move in any direction. Also, they can be easily compressed. They can be easily compressed, right? They can be easily compressed to form liquid or even solid and put into a small container, unlike solids and liquids. Since there is a lot of space between the particles, different gases can diffuse into each other. So different gases can diffuse into each other easily. Because why? Because there is a lot of space in between them. The kinetic energy, now you can see we are going to discuss about the kinetic energy. You know, kinetic energy is the energy of movement. Okay, so here kinetic energy between the particles is maximum in the case of gases because there is a lot of empty space. Therefore, the particles move around freely at a high speed and there is no fixed shape of gas. Clear. Now there is a comparison between solid, liquid and gas, difference in the characteristics of states of matter. So here we already discussed, you already know. Now we are going to consolidate all these things. Solid, it is definite in shape. In the case of liquid, it is indefinite shape. In the case of gas, it is indefinite shape. Clear? Now solids has a definite volume. Liquid also holds definite volume. But gas, it is indefinite volume. We cannot predict it is 2 liter gas or 3 liter gas. We cannot predict that. Now about the force of attraction in solid, force of attraction is maximum. Liquids compared to solid, the force of attraction is less, and in gases negligible force of attraction between particles. Clear? Now solids, it cannot be compressed, right? Liquid also cannot be compressed, right? And gas can be compressed. Now kinetic energy, think about the kinetic energy. Force of attraction is maximum in the case of solid, therefore kinetic energy is very less in the case of solid, and kinetic energy is more than solid, and here in gas kinetic energy of particle is maximum. So in liquid kinetic energy of particle is more than solid and less than gas. Now in solids, particles cannot move, rather they vibrate only at their fixed position. They cannot move because it is highly tightly packed, so they cannot move, but they can vibrate at a fixed position. Now about liquids, they can slide over one another. That's why fluidity, they can slide over one another. And in the case of gas, particles can move freely. Now about the density, it is tightly packed, therefore high density. It is density lower than in between this solid and gas. Liquid density is lower than solid, and the gas possesses the lowest density because there is a lot of vacant spaces in between the particles. Now solid, it cannot flow. Liquid can flow, gas also can flow. So this is the characteristics of different states of matter, that is solid, liquid and gases. I hope you all understood this till here. Now moving to another one, states of matter, that is plasma. So this solids, liquids and gases, you all know, right? Plasma is another one, that is the fourth state of matter, and in which particles are super excited. Here particles are super excited and super energetic. Energy, it is highly energetic and it is super excited. They are in the form of ionized gases. They are in the form of gas. Gas itself, it is highly kinetic in nature, so it possesses the highest kinetic energy, and it is ionized. That means it is super excited or super energetic. So what is plasma? Plasma is the fourth state of matter in which the particles are super excited and super energetic. They are in the form of ionized gases. Clear? Now, for example, fluorescent tubes, fluorescent tubes, right? And neon light bulbs, right? Neon light bulbs, that's also, consist of plasma. So when some of the examples where you can find the plasma is fluorescent tubes and neon light bulbs, okay? Now, the neon bulbs contain neon gas. So what they contain, and in neon bulbs, what it is, they are neon bulb, as the name implies, it contains neon gas, and there is another gas such as helium in the fluorescent tube. As electricity is passed in the tube, what happens? When electricity is passed through the tube or bulb, these gases inside the bulb or inside the fluorescent tube, these gases, which are the gases, neon, one gas, helium, another one gas, these gases gets ionized, and this creates the plasma inside them that glow, right? In fact, the sun and the stars glow being in plasma state. Here are some examples of plasma, right? Stars, okay, twinkling stars, lightning form of plasma, neon light, okay, neon light, that light, the particular color, plasma TV. These all are some of the examples of plasma. Now moving to the fifth state of matter, that is Bose-Einstein condensate. I already told you Jagadish Chandra Bose, he is an Indian scientist, Jagadish Chandra Bose. Now and Einstein, right? It is they together found this Bose-Einstein condensate. It is the fifth state of matter discovered by Albert Einstein on the basis of the studies conducted by an Indian scientist, Satyendranath. Sorry, I'm really sorry. I'm really, really sorry. It is not Jagadish Chandra Bose. It is Satyendranath Bose. I'm really sorry. I'm really sorry. Bose-Einstein condensate is formed by condensing gases, condensing. So here condensing gases of extremely low densities to much lower temperature. So that is Bose-Einstein condensate. These are the five states of matter: solids, liquids, gases. Among them, solids, liquids, gases, you have to study thoroughly. Then comes plasma. Where you can find plasma? What is the nature of the plasma? It is ionized gas of helium and neon. All these things where you can find plasma. All these things you have to study. Now the fifth state of matter is Bose-Einstein condensate. It was, I am really sorry guys, it is Satyendranath Bose, not Jagadish Chandra Bose. Satyendranath Bose, and it was discovered by Albert Einstein on the basis of the studies conducted by Satyendranath Bose, right? Now, interconversion of states of matter. I'm moving a little bit faster, right? So I have to complete this. I'm really sorry. You can uh, decrease the speed of the video in there itself, okay, if you want. Interconversion of states of matter. Interconversion. How you can convert the states of matter. You know the states of matter, solids, liquids and gases. And here we are going to discuss only about solids, liquids and gases. So here how you can convert solid to liquid, liquid to gas, or either solid to gas. All these things we are discussing here. So water exists in three states that you know: ice, water, solidification, or you will get ice. Water itself, it is liquid, and when you are boiling it, you will get gas. So water vapor, you know, gas, right? Water vapor is the third form gas. This is an indication that matter can change its state. That is, solid can be interconverted to gas, so liquid, and then from liquid it can be converted into gas. And also the gas can be converted to liquid, and liquid can be converted to solid also. So that means matter are interconvertible, right? So effect of change of temperature, how you can change this matter into different forms, that we are going to discuss here, and on the basis of temperature, how temperature helps in changing this matter. Okay, here solids, as we heat solids, you're going to heat solid, right? You're going to heat solids, okay? So listen here, all of you. So we are going to heat solids. For example, I'm going to heat some sugar, or I'm going to heat some salt, or whatever it is. The kinetic energy between the particles of solids increases. So what happens when temperature, when I'm going to heat it, what happens? The kinetic energy between the particles of solids increases. Okay, now this is solid particle, so I'm going to heat it. What happens here? So what happens here? I'm going to heat it. What happens? The kinetic energy increases, and which decreases the force of attraction. So which decreases the force of attraction means kinetic energy increases, means the intermolecular space increases, right? So which decreases the force of attraction between them. They start vibrating and changing their position. So what happens? Already we told that solids, they are vibrating at a fixed position, on its own position, right? So when you are giving some temperature, okay, what happens there is they are started to change their positions slowly due to heat. The particles become free and the solid converted to liquid. So what happens ultimately? It changes state to liquid. It changes its state to liquid. Now you know that caramelizing sugar, right? Right. When you are heating sugar, what happens? It just changes its state, that is solid state to liquid state, right? Now melting point. The temperature at which a solid melts to become a liquid at atmospheric pressure, that is called the melting point. So one question is there, one mark question, what do you mean by melting point? Melting point is a fixed temperature at which a solid melts to become a liquid at the atmospheric pressure. Listen here, at the atmospheric pressure, that you have to point out. For example, melting point of ice is 273.16 Kelvin. Kelvin is the unit that you already studied. So Kelvin. So what happens here is the melting point at a fixed temperature, or a fixed point temperature. So it is 273.16. That is the 273.16. Now fusion, another one term, fusion. The process of melting of solid into liquid is called the fusion. So what is melting point? Melting point is a fixed temperature. What is fusion? The process of melting of solid into liquid is called a fusion. The process of melting of solid into liquid is called a fusion. I think it's clear. What is melting point? What is fusion? What is the effect of change of temperature? When temperature increases, what happens? Kinetic energy increases, and which decreases the force of attraction between them, and they start to vibrate and change their position. So slowly they convert it into solid to liquid. Clear? Now you can see this diagram. So what happens here is solid. When you are adding energy in the form of heat, it changes to liquid. Clear? In the melting process, so now you studied about melting point. Melting point is a fixed temperature, and fusion is the process of conversion of a solid to liquid. In the melting process, once a solid reaches its melting point, its temperature does not increase further. So once it is reached the level 273.16 Kelvin for ice, what happens? It remains in that particular temperature. It remains in that particular temperature for this complete fusion process. Okay, that means ice completely melts to water. That complete fusion process to 73.16 Kelvin. The heat present in the solid at time of melting is used by the particle to diminish the force of attraction between each other. The heat energy is therefore considered as hidden. So here, this heat present in the solid. Now we are supplying heat. Now this heat at the time of melting is used by the particles to diminish the force of attraction. This giving heat, it is used to diminish the force of attraction between each other. Therefore, the heat energy is therefore considered as hidden. Now the related terms related, okay, some of the terms related to this melting point, heat, we are providing heat, that's all those things. First one is latent heat. Okay, latent heat, all these things are important, right? Latent heat of fusion, atmospheric pressure, all these things are important. So latent heat means the heat energy which is used to break the force of attraction between the particles of matter. So we now already told that the heat energy, it is hidden. So what is the heat? Heat energy is hidden. What is that heat is used for? It is used for the conversion of that solid to liquid, right? At that particular point, at that particular melting point, after reaching that particular melting point, it will not increase. Why it is not increasing? But we are still giving the heat. We are still giving the heat, but the temperature is not increasing. Why? Because the temperature that we are providing, it is used for the separation of this particle or to increase the space between them, right? So that heat, it is hidden. So that heat, then a heat energy which is used to break the force of attraction between the particles of matter is known as latent heat, right? Since the heat is hidden, therefore it is called latent heat. So latent heat means it is there. Actually, we are providing heat, but it is hidden. That's why the name latent heat. So the heat energy which is used to break the force of attraction between the particles of matter is known as latent heat. I hope you understood, right? Okay, latent heat, that is the heat energy which is used to break the force of attraction between the particles of matter is known as latent heat. Now, next term, that is latent heat of fusion. Latent heat, now you know, latent heat, that is the hidden heat. Now latent heat of fusion. The amount of heat energy, now here we are latent heat, here only we are discussing about the heat. Okay, the heat. Now heat of fusion means, fusion, you know, the process of conversion of a solid to liquid, right? So here latent heat of fusion means the amount of heat energy, how much amount of heat energy that we provide or required. So the amount of heat energy required to change 1 kilogram of a solid into liquid at atmospheric pressure at its melting point is known as latent heat of ocean. I hope you understood, right? All of you, please listen here. Please listen here. Listen calmly. So what is this latent heat? Latent heat means the hidden heat. That is the heat energy which is used to break the force of attraction between the particles of matter. Okay, and latent heat of fusion means that is the amount of heat energy required to change 1 kilogram of a solid into liquid at atmospheric pressure at its melting point. Okay, now atmospheric pressure means, atmospheric pressure is the pressure exerted by the weight of the atmosphere. So pressure exerted by the weight of the atmosphere, that is atmospheric pressure. It's very, 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 very important. What is latent heat? What is latent heat of fusion? What is atmospheric pressure? Moving to liquids, effect of temperature in liquids. Okay, so that is the thing we are discussing here. Just like solids, kinetic energy of the particles when you are giving heat, when you are giving temperature. Okay, this is the indication we are providing heat. Okay, up arrow. Okay, so here just like in solids, the kinetic energy of the particles of liquids also increases. You know, while you are going to boil water, what happens? Water, boiling water, right? Water you are boiling. That means you are giving heat, right? So what happens is the water gets ultimately converted to water vapor. Okay, think this is our task. Okay, we are going to heat water. So what happens here is the kinetic energy of the particles of liquid increases. While you are giving heat to the water, what happens? The kinetic energy increases. That means the force of attraction of them, force of attraction increases, but space increases. Attraction, force of attraction decreases. Force of attraction decreases. And they start moving freely, that means in the space, in the particle space is increasing, right? Okay, again I will draw. So this is actually for liquid. Okay, when you are heating, what happens here is in the particle space increases, that means force of attraction decreases, that means kinetic energy of the particle increases, right? As we keep on supplying the heat, a point comes when the particle overcomes the force of attraction completely. This is when the liquid starts changing into gas. That is a particular point where boiling point, that is the temperature at which a liquid starts boiling at atmospheric pressure is known as boiling point. For example, the boiling point of water is 373 Kelvin. You know 100 degrees Celsius, right? 100 degrees Celsius plus 273, that is, we are going to convert it into Kelvin. You will get 373 Kelvin. Okay. Now, latent heat of vaporization. Now, previously we studied about latent heat of fusion. Now, latent heat of vaporization. Here also hidden heat is there, right? So here the amount of heat energy required to change 1 kilogram of a liquid into gas at atmospheric pressure at its boiling point is known as latent heat of vaporization. Same, we are converting into liquid into gas. There, what we did then, latent heat of fusion, that is the amount of heat energy required to change 1 kilogram of a solid into liquid at atmospheric pressure at its melting point. In this place, melting point. Here it is boiling point. Now, what happens when temperature is decreased? Okay. Now, till now we are discussing about what is the effect of temperature on solids and liquids. Now the next question is what happens when temperature is decreased. Okay, you're going to decrease the temperature. So for that, gas. Okay, gas. So gas, the kinetic energy between, okay, you're going to decrease the temperature. Makkale, listen here, you're going to decrease the temperature. So what happens? Decreasing the temperature means now it is in water vapor. Water vapor, you are going to decrease the temperature. That means you are going to put the water vapor in a freezer. Okay, listen here. Okay, you're going allowing water to cool. Right? Again, you are cooling. When you are keeping it in freezer, what happens? Temperature going down, and ultimately you will get ice. Right? Ice means what happens? It is tightly packed. It is solid. So what happens here? Water vapor to ice. Okay, water vapor to ice. Water vapor to ice. Okay, water vapor to ice. Now listen here. What happens to kinetic energy? Kinetic energy between the particle decreases and they turn into liquid state in the case of gas, right? Condensation or liquefaction, another one important term that you must study here. The process of converting gas into liquid by cooling down is its temperature is called condensation or liquefaction. 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 For example, the formation of clouds is due to the condensation of water vapor from earth. So you already studied it in 7th standard, right? What do you mean by condensation? What do you mean by precipitation? All these things you study. So it is very easy for you. Condensation means the process of converting gas into liquid by cooling down its temperature. Okay, that is the thing about gas. What happens here? When you are lowering the temperature, kinetic energy decreases. Clear? Now we are moving to the liquids. What happens in the case of liquids? In liquids also kinetic energy decreases and it turns to solid state. For example, the formation of ice. Now listen here, this is another one term that you have to study, that is sublimation. The change of state of a gas directly into solid and vice versa is known as sublimation. For example, camphor. You are keeping camphor. It is camphor. What do you mean by camphor? Camphor, you are going you are using this camphor, right? So camphor is a solid, white solid actually, and it directly evaporates into air. It's solid, directly evaporates into air, that is gas, without changing into liquid state. That particular uh, term is called, or that particular process is called a sublimation. Makkale, all of it, please listen here. One more thing I'll tell you. You know naphthalene bolts, right? Naphthalene bolts that you are going to get rid of this cockroach naphthalene bolts you are using, right? And this naphthalene bolts, mainly you are keeping it in bathrooms, toilet areas, or kitchen areas, right? What happens after 2-3 days? What happens 2-3-4 days? What happens? In naphthalene bolts, you cannot see this naphthalene bolts. There, what happens? The process is sublimation happens, that is naphthalene bolt directly changes its states from solid to gas. Solid to gas, right? Therefore, by increasing or decreasing the temperature, we can change the state of matter into one another. Okay, so by increasing or decreasing the temperature, we can change. So this is the typical or consolidation of what we studied now. States of matter, change triangle. So this is our solid ice. Haha, you can see here our Coleman snowman is here. So this is solid ice, and this solid gets melted to form, melting to form, or liquefaction, or melting to form our liquid, that is rainwater, and gets evaporated to form gas or vapor. And solid directly converts its states to gas is called sublimation, right? Then reverse also sublimation. Now this water condensed to form solid, that is freezing or solidification, and here solidification, freezing or solidification. Water changes to ice, that is freezing or solidification, and vapor changes to water is called the condensation. Clear? Okay. All of you, please listen here. This is the thing that we studied till now. States of matter, how they can be interconvertible. So solids can be converted to liquid by solidification, liquefaction. Solid converted to liquid by melting, or liquefaction, LIQUE, liquefaction. Then liquid convert to gas by evaporation. Okay. Now, gas can be converted to liquid by condensation, and liquid can be converted to solid by solidification or freezing. Ice is freezing. Okay, water is freezing to form ice. And the solid can be converted into liquid. Solid can be converted into, gas. Solid can be directly converted to gas through the process of sublimation. 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 Okay, I hope you understood. Now we are moving to the effect of change of pressure. What happens when you are applying pressure to solid, when you are applying pressure to gas, when you are applying pressure to liquid? So you know that applying pressure means you are applying pressure on something, means its volume decreasing, right? So what happens here is there is a piston. Okay, this is a syringe. Okay, all of you please listen here. This is your syringe. Okay, syringe. Okay, syringe. So what happens now? The volume of this syringe is 5 liter. Oh, sorry, 5 milliliter. Okay. Now what happens? I'm going to I'm going to apply pressure on this piston. I'm going to apply pressure on this piston. So what happens? The volume reduced to this much. Okay, now this is the pura volume, that is 5 ml. Now I am going to applying pressure on this piston. So what happens? The piston moved to here. Okay, moved to here, piston moved. Now what happens? 5 minus 2, that is 3 ml. So what happens when you are applying pressure, volume decreases. Applying pressure, all of you please listen here. Applying pressure means volume decreases. Okay, so volume decreases means interparticle distance decreases. Interparticular distance decreases means it gets converted from gas to liquid to solid. Right? Now we are seeing, by applying pressure, we can bring the particles of matter close to each other, thereby increasing the force of attraction among the particles. When we compress and decrease the temperature of gas, the gas changes into liquid, right? Gases changes into liquid. Why? While you are applying pressure, volume decreases. That means interparticle distance decreases. That means force of attraction increases. That means force of attraction increases. Force of attraction increases. Increases, interparticle distance decreases, force of attraction increases. That means gas changes to liquid. Dry ice. What is dry ice? Carbon dioxide in solid form is known as dry ice. Carbon dioxide. Okay, one more question. Dry ice. It can directly turn to gas by decreasing the pressure to 1 atmosphere. So dry ice means carbon dioxide can directly turn to gas by decreasing the pressure to 1 atmospheric pressure. Okay, moving to the next one, evaporation. Very important, and this is our last portion, evaporation. You can see a typical diagram of evaporation. Evaporation mainly happens on water molecules. Very easy to explain in the case of water molecules. So this is water molecule, this is O, and these are the two hydrogen atom, right? This is O, and these are the two hydrogen atom. So what happens here? The upper layer. This is the upper layer of the water. Okay, the upper layer of the water means this water molecule gets evaporated. That means it gets changes its state to uh, liquid to gas. Right. Okay. We are going to discuss it. So evaporation, we already know that particles of matter are never at rest. They are always vibrating motion. Even in a solid also, they cannot move each other, but they are at their fixed position and they are vibrating. So particles of matter are never at rest. Particles of matter possess different amounts of kinetic energy. That also we discussed in the case of solid. There is no kinetic energy. It is particles are very much definitely arranged, and there is no interparticle distance, and force of attraction is very large. But in the case of gases, kinetic energy is very much, and they can move freely, right? And the particles of liquids have more kinetic energy. Liquids particles have more kinetic energy, and compared to solids, not compared to gases, right? So therefore they are able to overcome the force of attraction and convert into vapor without any external force. So they can be converted. So these liquids can be converted to gas. Liquids can be converted to gas because there is some particle distance is there. So they can be converted while you are giving some heat or something. So evaporation is the phenomenon of change of liquid into vapors at any given temperature below its boiling point. Okay, below its boiling point, they can be converted into vapor. Evaporation, the phenomenon of change of a liquid into vapors at any given temperature below its boiling point is called evaporation. Evaporation is different than boiling. It is not boiling because boiling, you know, at a particular point, boiling point at a particular temperature. So here evaporation happens at any temperature below its boiling point, at any temperature below its boiling point. So it is different from boiling. You can see here, this is evaporation. Okay, this is boiling. So here you can see, here vapor pressure is less than atmospheric pressure. Bubbles cannot form. Here there is no bubbles, there is no bubbles. But here, look at here, vapor pressure is equal to atmospheric pressure and bubbles can form and rise. Here bubbles can be formed. So both are different. Both are different. Now factors affecting evaporation. Okay, listen here. All of you listen here. So which are the factors that affect the evaporation? When you increase the surface area, okay, listen here, all of you listen here, I'll give you some day-to-day life experience, okay. You're going to dry your washed clothes, okay, and there is no space in your rope. So many clothes you washed, and there is no enough space in your rope. So what happens? You will ultimately you will like this, okay. Okay, there is no space. So what happens? If rate of evaporation is very low. What happens? Rate of evaporation is very low. In order to increase the rate of evaporation, we have to tie another one rope and keep your clothes perfectly, right? Then what happens? Evaporation takes place easily. Evaporation takes place easily, right? So increase in surface area. Here surface area is very high compared to this one. Okay, so increase in surface area increases the evaporation. Increase in surface area increases the evaporation. Reason is particles have more space and this can evaporate easily. You can see more space is there, so they can be evaporate easily. Now increase in temperature. You're going to dry your clothes in sunny day, and you are going to dry your clothes in a rainy day. Okay, so what happens here? In cloudy day or in a rainy day, what happens? The rate of evaporation is very less. And in sunny day, the rate of evaporation is high, right? So sunny day means temperature is more. So increase in temperature increases the evaporation. Why? Kinetic energy among the particles increases. Kinetic energy among the particles increases. Similarly, increase in humidity. Same thing, cloudy day and sunny day. In which day humidity increases? Cloudy day, humidity is more. Humidity is more for cloudy day. So what happens with the rate of evaporation? Decreases. So humidity, rate of reaction, rate of evaporation decreases. So water content in air increases and so evaporation decreases. Now increase in wind speed. I'm going to dry my clothes in a place where there is lot of air is there or lot of wind is there. Then what happens? In evaporation, rate of evaporation increases. So water vapors are blown away from the winds, allowing more evaporation. So which are the factors that are affecting the evaporation? Surface area, SURFACE, surface area. Next comes temperature, ST, temperature. And then comes humidity, 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 STH, and then wind speed, STHW, wind speed. Okay, okay, listen here. Here surface area, temperature, humidity, wind speed. Listen here. All you need to do is just imagine you are going to dry your washed clothes. What happens? See, increase the surface area, rate of evaporation increases. Then increase the temperature, rate of evaporation increases. Increase the humidity, rate of evaporation decreases. Then comes our wind speed, rate of evaporation. Increase the wind speed, rate of evaporation increases. Okay. Now moving to the last and one and only concept, that is evaporation causes cooling. But whenever in a hot sunny day, you're going to take bath, right? You're going to take bath, and your body temperature is very high. Okay, your body temperature is very high, and after bathing, suddenly you're getting out from the bathroom. What happens? Your body temperature is very low. So evaporation there, what happens? There is evaporation. Okay, evaporation happens there and it causes cooling in your body. Okay, you might have experienced in a sunny day. Okay, while you are going to bathroom, all the bathroom is full of hot because of your body temperature, and while you are stepping out of the bathroom, what happens? Cooling. Cooling means your body temperature just that means just the surface of your body just feels some cooling. That is because of the evaporation. Okay, the process of evaporation uses the energy of liquid particles. So the process of evaporation, what they use the energy of the liquid particles. Therefore particles absorb energy from the surrounding in order to compensate the energy that is being lost in the process of evaporation. Okay, this result in cooling of surrounding area. Here, Makale, listen here to this figure. High energy evaporating causing. Medium energy pull back to water. Lower energy remains as liquid. So high energy needed for evaporation. So that high energy, where it get that high energy, it is from the surrounding, and because of that, cooling occurs. For example, our palms feel cool when we put some acetone on it. Nail paint remover, while you are adding nail paint remover, or while you are dipping your nail paint remover, or while you are applying remover, what happens? Okay, so cooling, you will get a cooling effect. That is because of the evaporation. Okay, now people sprinkle water on their roofs or grounds on sunny days to cool the area. People sprinkle water on their roofs or grounds, that you know. We are able to sip hot tea faster in a saucer than in a cup. So in a cup there is no surface area, right? So surface area is very less, right? So you are able to sip hot tea faster in a saucer than in cup. That means what happens there is evaporation happens there. Evaporation happens there means uh, it will collect the energy from the surroundings, and that's why cooling happens, right? So this is one more, and for you, this is the task for you guys. The question number one is, why people wear cotton clothes in summer? Think logically. Think logically. Answer it, and please mention your answer in the comment section. Okay, think logically. Why people wear cotton clothes in summer? Okay. Now the second question is, why water droplets appear on the surrounding of a glass with ice cold water? You are taking ice cold water in a glass. right? Water droplets appear on the surrounding of the glass with ice cold water. Why? You have to answer this. Okay guys, this is all for this chapter, that is matter in our surroundings. I hope you will get this chapter, and I hope you will get all these questions. You can, I hope you guys can answer all the questions from this chapter. Okay, so thank you all. Thank you.